Good morning. Myself Divya Kumar, Assistant Professor from SNS College of Technology. In this lecture series, we are going to discuss about data acquisition system. Here are some of the topics we are going to discuss. Introduction to DAS, objective of DAS, block diagram, methodology, hardware and software for DAS, merits, demerits, and conclusion. First, introduction. Data acquisition is the process of sampling signals that measure real-world physical conditions and converting the resulting samples into digital numeric values that can be manipulated by the computer. Data acquisition system typically convert analog waveforms into digital waves for easy processing. Now the question arises, what is data acquisition? It is the process of measuring an electrical or physical phenomenon such as voltage, current, temperature, pressure or sound flow rate into a computer. Here are some of the components of data acquisition system. The first major important component is sensor, which is used to convert physical parameter to electrical signals. Second most important is signal conditioning circuitry, which is used to convert the sensor signals into a form that can be converted into a digital signals. And then analog to digital converter, which convert conditioned sensor signals into digital signals. Next, we are going to discuss about the objectives of DAS. It must acquire the necessary data at correct speed and at correct time, and also it must monitor the complete plant operation to maintain online and safe operations. It must be able to collect, summarize and store data for diagnosis of operation and record purpose. It must be flexible and capable of being expanded for future requirements, and also DAS is able to compute unit performance using online real-time data, and also it must be reliable, easy to operate and must be user friendly. And this is the block diagram of data acquisition system. First physical system, then transducer, then signal conditioning and analog digital converter, and then computer. First one is physical system or conditioning. Physical condition that can be used as input of DAS or which can be represented in a digital form as under. Some of these are temperature, pressure, light, force, displacement, level, electrical signals, etc. Next one is transducer. A transducer converts temperature, pressure, length, position, etc. into different forms such as voltage, current, frequency, pulses or other signals. A transducer thus converts the physical conditions in electrical waveform for easy signal processing. It converts a physical phenomenon into a measurable electrical signal. It is a major purpose of the transducer. Next, these are some of the varieties of the transducer. In temperature, in order to measure the temperature, there are different types of devices such as thermocouples, resistant temperature detector, thermistors, etc. If you want to measure the light, there are some of the transducers such as vacuum tube, photosensors, photoconductive cells, etc. And then for the measurement of sound, microphones. And measurement of force and temperature, there is a strain gauges, load cells, piezoelectric transducers, etc. For the measurement of position, there is a potentiometer, linear voltage differential transformers, optical encoders, etc. And for the measurement of fluid flow, rotational flow meters, ultrasonic flow meters can also be used to measure the fluid flow. For the measurement of pH level, pH electrodes are there. Next important component in DAS is signal conditioning. Signal conditioning circuit improves the quality of signals generated by transducers before they are converted into digital signals by data acquisition hardware. Most common signal conditioning functions are amplification, linearization, cold junction compensation, filtering, attenuation, excitation, common mode rejection, and so on, etc. Here is in signal conditioning unit, a noisy low-level signal is converted into amplified signal and also it gets filtered. It is one of the major important function in the case of signal conditioning. Low level signal is converted into an amplified higher level signal and also the noisy signal is filtered in the signal conditioning component. It also improves the quality of the signals by amplification, filtering and isolation. What is amplification? When the input signal is as small as microwatts, electrical noise can draw out of the signal itself, leading to meaningless data. For reducing the effect of noise on your signal is to amplify the signal as close to the source as possible. That is, example, AJ type thermocouple outputs a very low level voltage signal that varies by about 50 microvolt. And then filtering, to reject unwanted noise within a certain frequency range. Many systems will exhibit 50 Hz periodic noise from sources such as power supplies or machinery. Example, Butterworth filter, Whistle filter, Simply RC filter are some of them. And then isolation. Improper grounding of the data acquisition system is the most common cause of measurement problems and damaged DAQ boards. There is no physical wiring between the input and the output. The input is normally transferred by converting it to an optical or magnetic signal, then it is reconstructed on the output. Isolation is one way to eliminate ground loops. Isolation breaks ground loops, rejects high common mode voltages and product expensive DAQ boards, products from power lines, lighting, etc. And next important function is analog digital AD converter. Analog to digital conversion changes analog voltage or current level into a digital transformation. The conversion is necessary to enable the computer to process and also to store the signals. Thank you. In next video, we are going to discuss about methodology.